charts, you need to be visiting me now. Now, immediately, or make a phone call, or some kind of Hail Mary at this point. Because if you were gonna use test 1 as your drop, you won't be able to drop test 2. Great. Which is the only one you can't maximize or minimize? Cost. Why? Yeah, there's no peak or valley. Okay? So which ones do we maximize?
Revenue and profit.
Profit and revenue. Which one do we minimize?
Cost.
No.
I mean, sorry, average cost.
Average cost. Right? That one right there. What is FC?
Fixed.
And what's special about fixed costs? It's where what?
0.
X equals 0, right? So X equals 0 here, but cost doesn't. So you can use that to find your nugget. Nuggets are explicit for everybody except revenue, at least on these 4. All right, these are the big 4. You're gonna need to know these, right? And the nugget for revenue is always 0, 0, because of the nature of it. It always starts at 0, 0. How do you maximize profit?
The marginal profit, the thing that we just did.
Jesus Christ. Okay,
I'm not wrong.
maximum profit is right here. What's special about that spot, guys? The slope is 0. So you take the derivative, set it equal to 0, solve for the x. If I ask you to find max profit, where do you shove that x?
Into the profit function.
Into profit, which gives you the corresponding max profit, yes? Okay, how do I minimize average cost? Take the, wait, chandelier.
Can you just say right now?
Can I what?
Oh, nothing negative.
Yeah. So I maximize profit by taking its derivative, setting it equal to 0, and solving for the x that gives me that spot.
Okay.
Then I take that x and I shove it back into profit. That gives me the corresponding profit fund,
Okay.
or profit value.
Thank you.
Great, you're welcome. So how do I minimize average cost? It's not helping my migraine, but I'm doing it anyway. I'm just gonna keep bumping myself until you guys get it.
Dang, I feel
How
bad
do
for
I
your head.
minimize average cost?
She's gonna have brain damage after the class.
Something integrals.
Oh Jesus, come on you guys. How did I maximize profit? Took the derivative. I did what with the derivative? I set it equal to 0, and then I did what with that? Plugged it, I didn't plug that in. I solved for x, and then I took the x and I plugged it in,
The original
plug it into the original function. It's the same thing, guys. How do I maximize revenue?
The derivative, find x, plug it into the function, all that.
Take the derivative, set it equal to 0, solve for x, plug the x value in to the revenue, and you get maximum revenue, okay? Yes?
Yeah.
Groovy. Good, because my head's about to spin. Okay. What if you can't factor it?
You put it in your graph, or your calculator, you graph it in your calculator.
When in doubt,
Graph it out.
graph it out, guys.
Put it in your graph.
Graph it out. What are you graphing?
The function.
The derivative. It is not a red
Derivative
balloon.
of the function.
It is the derivative of the function. And in that case, you're gonna get either something that looks like this, or you're gonna get something that looks like this. Okay? Where it crosses the x-axis is where the slope is 0, because when you're graphing the derivative, you're graphing x versus slope. Positive slope, 0 slope, negative slope, okay? So it's either some positive slope going to 0, then goes negative, or it's some negative slope going to 0, then going positive. So the original function for this one looks like this. The original function for this one looks like this, right? Okay, you remember that. So if we take the derivative and set it equal to 0, and we can't easily solve for x, graph the derivative, f prime, whatever it happens to be. And then you find this point, that x value. How do you do it?
Equal to 0.
Second calc, arrow down to 0. It's gonna prompt you for left bound. Left bound in this case is up here. It's like dropping a car on the road. Right bound is here, and then it'll converge to the solution. In this case, left bound is below, so you're looking for a negative y value. Right bound is above, and then it'll converge to the solution. Okay, so if you hate factoring, this is for you. All you have to do, guys, is have enough enough y min, so you want your y min to be something negative, some negative number, and you want your y max to be some positive number, and you want your x min to be 0. Why do we want it to be 0, guys?
Is that supposed
No. What is x?
The units.
Units. Can we have negative units?
No.
No,
Right
so
units.
we don't need negative x. So we can set our x min to 0. And just the only thing you have to do here, guys, literally, is make your x max big enough to see the function cross the axis. You just have to expand, so if you're out here, you're clearly not gonna see it. Make it bigger until you see this line cross the axis. That's all you need, and then you can calculate it. Okay?
So then whatever that x value is, then we plug that into the original function to get out.
The max or min, whatever. Yeah, exactly. So this solution here is gonna be this x value here, or this x value here, or this x value there. Whatever it happens to be, okay? Chapter 10 is graph heavy, yes, but it's not that bad, okay? What's the only other thing we need to know from chapter 10? Sure, concavity. So I'm gonna put something over here. And did I do this on the board with you guys? I know I've done it with all the students that have come in asking about chapter 10. So I'm gonna give you the 5-minute chapter 10 summary. Yeah, this is gonna look familiar to some of you. So if we have an original function that looks like this, tell me where the slope is 0. Just tell me where. Here,
Right there.
here,
Right there.
and here. So f prime equals 0 at both, or all 3 of those spots, right? Okay, so those are my critical values. Let me draw those on the x-axis. So here, here, and here. Those x-axes, these are a critical value, this is a critical value, and this is a critical value. So how do we get critical values? We find where the slope is 0, and how do we do that?
Take the derivative, set it to 0,
Then solve for x, right?
and then you plug x into the double derivative. You plug all your x's actually if you have more than one.
Yeah, f prime tells you where the critical values are. F double prime tells you what they are.
So I have a question
Yeah,
on that. So like say you have 3 critical values, like one of the examples in the homework was like your critical values were 2, -2, and 0.
Mhm.
And so I plugged all those into the double derivative,
Mhm.
and one comes out negative, one comes out positive, and one's 0.
Good.
But so in that instance, you know which one's your HPI, but like what if, how do you tell what your HPI is? Like what if it had come out a negative, or what if it came out with 2 positives and a negative?
It wouldn't.
Like,
It wouldn't.
so what is it? Is it always 0 then? Like how do you know what your
Well,
HPI is?
let's go a little bit further with this, guys. What kind of second derivative does this point have? Positive, negative, or 0?
It's gonna be negative.
It's a sad face, right? That's a sad face. So whatever this x value is, if you plug it into the second derivative, it's gonna give you a negative answer. Okay? A 0 slope and a negative concavity is a maximum. Let's look at this one. If I plug this critical value into the second derivative, what kind of sign am I gonna get?
Positive.
Positive. Some happy face. This is a minimum, guys. And if I plug this critical value, the one in the middle, into my second derivative, what am I gonna get?
0.
Yes, this is an HPI. So
So
again,
it's
F prime tells you where they are. You identify the locations of your critical values. The second derivative tells you what they are. So a maximum has a 0 slope and a negative HPI. Or sorry, damn it, my apologies, strike that. Slope of 0, concavity that is negative. Okay, so all you care about is the sign of the answer here. You don't care about the number itself, just the sign.
So just because the first derivative gave a critical value of 0 in that example I said,
Yeah.
does it mean that, like, doesn't mean it's always gonna give you a 0?
Right, so when
Like
we're
it's-
dealing in application problems, you already know that revenue is gonna have a maximum, not a minimum, right? Because of the nature of the function. And average cost is gonna have a minimum, not a maximum. So you don't need to do the concavity test here. It's only with the pure math that you would need to do a concavity test, guys, so that you can figure out what each of these critical values are they
And it-
maximum, minimum, or HPIs.
It's an HPI if the double derivative is 0.
Yeah, if the critical value at the double derivative is 0.
Right.
Okay, yeah, so the steps here are you take the derivative, you set it equal to 0, you solve for x. Those are your critical values. Then you take those values and you shove them into the second derivative. The sign of the answer determines what the thing is, and this is on your tattoo. Grab your tattoo. So this should help you guys a lot, this right here. This should help you guys a lot. If you plug an x into a second derivative, you get out concavity. If you plug x into a first derivative, you get out slope. Slope can be positive, 0, or negative. A negative a 0 indicates a max or a min or an HPI. So we don't know which one it is until we put it into the second derivative. So F double prime gives you concavity. Concavity will give you a positive sign, a negative sign, or a 0, and a 0 indicates a point of inflection. The signage, positive and negative, indicate max or min just by the shape of them, right? This contains a maximum, doesn't it? So a sad face contains a max. A happy face contains a min. Autumn.
How did you know that the second derivative would be negative there because it's a negative slope afterwards?
No, concavity. A second derivative is concavity. It's not about slope.
Or what was the function? Do we need to know the function in order to get the second derivative or no?
Yeah, you'd have to know or you'd have to be given the second derivative, right?
So this is just hypothetical?
This is hypothetical, but it's good for all of them because these are the 3 results you could possibly get. Okay? Yes?
So would you just graph your function right away to see what the picture looks like, so
You could if you wanted to. But if I ask you to use the second derivative to figure out if it's a max or a min or an HPI, you're gonna have to do the math anyway.
Then you take the function, get the derivative, take the second derivative.
Take the first derivative, set it equal to 0, gives you critical values. Plug those critical values into the second derivative and it'll tell you where or what they are. Okay? Adam?
can we do a problem?
Yeah, we can.
With numbers?
Yeah, we can. There's one more thing I want to put on the board from chapter 10, guys. And it's the point of diminishing returns. Chandelier.
So for you to know whether compare up or down, you have to take the critical values and plug them into the second derivative.
Yes, so this second derivative of this particular critical value will give you some positive answer. All you care about is the sign. Okay, so you're literally taking this x value, whatever it is, and you're shoving it into the second derivative to see what happens. Okay, and you can verify this by graphing it. You can always graph it, guys. Just like, was it Adam or Marco that said that?
Said what?
Or was it you,
Ask
Adam?
questions, by the way.
It was what?
What, ask questions at the same time.
Oh, you did? Same thing.
Oh, that one, if we could do
Okay.
one with numbers?
Can you graph it? Yes, of course you can graph it. You can always graph it, okay? I can't stop you from graphing it, my God, but I'll still want to see the work with the math, okay? And the last thing I need you guys to know from chapter 10 is the point of diminishing returns. I may or may not ask you to graph it. If I ask you to graph it, this is the picture I want to see from your calculator. And you can't just draw it and say, this is what it looks like. Tell me what your x min was. Tell me what your x max was. Tell me what your y min was and your y max. Where is the point of diminishing returns?
Halfway through.
Well, close. Maybe not exactly halfway through.
But when the concavity changes.
It's where the concavity changes. It's literally where f double prime equals what? So you can, if I ask you to find the point of diminishing returns on a problem, skip to the good stuff. Take the first derivative, then go ahead and take the second derivative, then set it equal to 0, then solve for x. That's it. Okay? All right. This is all
So,
chapter 10,
What's it called, point of diminishing return?
point of diminishing
And you
returns.
find it by setting the double derivative to 0.
Yeah,
Period.
period. That's it. Okay.
But it's also how you find concavity.
Well, I'm saying find the point on this function where concavity is 0. So I'm not finding concavity, I'm assuming a 0 concavity. Okay?
Yeah, I would be the
Hank,
same as that.
well, HPIs, look at what HPIs look like, they're flat. Okay, HPIs have a slope of 0. This does not. This is a different type of concavity change. Okay, yes,
So why is it,
Corwin.
so why isn't it an HPI?
It's not an HPI because HPIs have a slope of 0. This
slope of zero
flattens
and
out
the
briefly.
delivered.
Yeah, so an HPI has a slope of 0 and a concavity of 0. This is a non-zero slope, guys. This is where the slope is a maximum, isn't it? This is the steepest slope on this function.
But the concavity is
Concavity is 0. So it's a non-zero slope, but a 0 concavity. Okay, so it's a different type of point of inflection, which is why I said, specifically on the first derivative, I said 0 is a max or a min or an HPI, horizontal point of inflection. But on the second derivative, I didn't distinguish. I said it's a point of inflection, not necessarily horizontal. It could be a point of diminishing returns as well, okay? Every choice of language on this tattoo means something, all right? Everything, every word, every mark, everything means something here, okay? How do you guys feel about that? So we'll do a problem. It's the same problem you guys did in my office when you asked me about chapter 10. So some of you will have seen this problem already. Hopefully this helps. You're welcome. Did you thank me? Oh, you're welcome. Thought that's what I heard. But if you were like, F you, and I'm like, you're welcome, that would have been funny too. I know. I know it's not. And that's a good thing. All right. So I'm going to give you guys a fairly straightforward problem now.
So on the
You may see something, well, these are basically 3 different types of problems, right? There's the application problems, which use all the stuff in the middle. There's the pure math, which uses that over there. And there's the special application problem, which is specifically point of diminishing returns. And that one looks like this, okay? So those are really the 3 things you need to know from chapter 10. So I'm gonna erase all these pretty pictures. And then we're gonna do a problem. Okay. So, x cubed minus 6x squared plus 12x plus 1. 6x squared plus x cubed minus 6x squared plus x plus 1. So this is some function. And let's just say I want you to find critical values and ID them as maxima, minima, or points of inflection. Okay? So, how do we do it, guys? Find the derivative. What's f prime?
And set that equal.
We're going to set it equal to 0. Because first I said find them. So how do you find them?
Set the first derivative to 0.
And solve for x. So 3 Gesundheit. What? I'm sorry. You're good? What can I factor out of all 3 of these things, guys? 3. So if I do that, I get 0 equals 3 times x squared minus 4x plus 4. And if I divide both sides by 3, I know I'm going really fast, so hang tight, guys. I'll give you a second to catch up. Those will cancel, won't they? Heck yeah, they will. That's right, Ryan. Right, Bella? Yeah. Feeling good about this stuff now? Huh? Feeling good about this stuff now?
No.
A little better?
Yeah.
Just a tiny bit better? Okay, groovy. Okay, so now what do I have?
The x stays square.
The x will stay squared. Yeah. Which, I'm sorry,
Yeah.
Amon, which one are you? You're good? Okay. So what multiplies to positive 4 and adds to negative 4? Negative 2 and negative 2, right? So 0 equals x minus 2 times x minus 2. So x minus 2 equals 0. X equals 2. That's my critical value. Now, what is it? I know where it is now, but what is it? That's when I plug it into my second derivative. Very good. What's my second derivative?
6x minus 12.
F double prime equals 6x minus 12, right? Now plug it in. F double prime of 2 equals 6 times 2 minus 12. What do I get? 0. So 0 slope and 0 concavity indicates what, guys? Use this as your
Inflection.
it's an HPI. So this is an HPI. So the first derivative tells you what it is. The second derivative tells, or sorry, shit. The first derivative tells you where it is. The second derivative tells you what it is.
Would you?
Autumn, hang tight.
Could you have more than one value for critical values?
Absolutely, yeah, just like that problem has 3. Yeah,
Or if it was like 6x, maybe 2 times 3.
yeah,
Does this mean that in this case, there's no like max or min?
In this
Critical
case,
value.
there isn't, and if you graph it, you'll see. Here's what it looks like, guys. I'll put it right over
Like
here.
it'll give you the values, but it has it.
What do you mean it'll give you the values? What does that mean?
Like if it had a max value, like you would have had another x. If it had a max,
You would have another critical value, yes.
yeah.
Zero.
Absolutely.
I'm sure it will when we're all three on the board.
I don't know if I'm gonna.
That's what it looks like, guys.
Today you don't have to go. We'll probably do
So does that have a max?
We're gonna do it on Wednesday.
Does that have a min?
I was just not
Does
planning
it
on
have an
this.
HPI?
I'm just not ready for it.
Yes. And now you can see why. Questions?
So can we expect to see something like this on the test?
Yes, you can. That doesn't mean it's gonna be there. I'm saying you better know it. Ferris,
So when you factor, is it always gonna be like the two numbers are?
I can't hear him, guys.
So when you factor and you solve for x, you're always gonna have like two numbers that are the same, so like -2, which gives you 2.
Not always, but in this
What
case,
if you get
yes.
to different numbers?
Well, then you have two different critical values and you need to test them both,
See which one.
okay?
I mean, which one.
So whatever critical values you end up with, you gotta shove them both into the, or all three, or just the one.
And then they're both, so it will be like, both of them would be positive or both of them would be negative?
Not necessarily.
So it's positive for the minimum and the negative of the maximum.
Mm-hmm.
Oh.
Does that make sense?
Yeah, it all depends on the graph though.
Yeah, it all depends on the graph. So you can always graph it. I can't stop you guys from graphing it. But you need to show me the math that shows me that it's an HPI or a max or a min. I wanna see the work. That's what this is all about, okay? Blaine, is that a question or are you just like groovy? Okay, Marco.
One function can have an HCI and a maximum or minimum.
Absolutely it can, right? A function can look like this. It can have an HPI and a maximum. Damn straight.
So would the 2 be a minimum positive 2?
No,
Then that's not.
you have one solution here. These are the same thing.
Yeah.
So that one solution gives you an HPI.
Since they're both zero, yeah, that's why we got HPI.
So I'm fine.
We plugged it in.
Just reverse it, I won't do
Do you have an example with the minimum and maximum?
Okay.
It's your homework.
No, we're moving on. Corwin.
How do you get multiple critical values?
Multiple critical values, so when you factor, and let's say these were different factored terms, you would get two different critical values out of that, and you would test them both. Okay? Chandelier.
Can you get 3 of those? Like-
Absolutely.
Okay.
Yeah, absolutely. Okay. Am I gonna do that to you? Probably not. Be ready for it,
Come on.
okay?
Just do it. Just do it.
You guys know how
Put
to
us
do
out of our
this.
misery.
You do, you really do. Don't laugh.
No, no, no.
Oh, memo.
Okay, shall we keep going?
Just wanna make sure everyone's good with this problem before I erase it. You guys are happy, satisfied? My back row, my quiet row, this corner especially. Anyway, you're good. But what about you? What about you? Yeah.
How do you find the critical values without factoring? Did you graph it?
Yeah, so it's exactly what I did before. If you don't like factor and graph it, wherever it crosses the x-axis, what are you graphing though? That's the critical thing. You're graphing the derivative.
I'd rather do math all day. But
The
all I
first
do,
derivative.
I'm just like, I don't even know. I need to go over this video, like on the point where she showed me
Yeah.
how to find it.
Anywhere it crosses,
Oh, yeah,
anywhere
I
the
just did
derivative
that
crosses
today.
the x-axis is where the slopes are zero.
I never even used
Does that make
the
sense?
calculator until I came to this school.
Like, the graph and then the derivative of the graph, and have both of them, and then it'll just line up.
They will line up. Yeah, do you guys remember Let's Play Together in a Not So Creepy Way? That's exactly what that entire section was about. So grab that handout if you're curious. It's in there. It's from like chapter
Do you do
9.3.
the same like thing where you hit
I
cal
see yours, I see yours.
and to like find where the
Mhm.
it's crossing the x-axis?
Yeah,
How do
it's
you get that little cursor thing to see where it
the
is?
second
crossing?
calc, zeros.
Okay.
That's it. And then it asks for left bound, right bound. It's gonna prompt you. So you're gonna drop a car to the left of it, drop a car to the right
That's
of
the
the
same
point.
way to
And
find
it'll
the-
converge to the solution. It's the exact same thing.
Okay.
Yeah. Ferris, was that a question?
I was just.
Ruby, Blaine?
I was just gonna ask, is there ever any points that you would have to look for crossing the y-axis or not just the x-axis?
Not just the x-axis. It's all about the x, always. Okay. Adam, I wanna make sure you're good. Quiet. Is it Mitch? Mitch, how are you? You're good? Tyler?
Yeah.
You're good? And remind me, what's your name? Natalia, are you good? Awesome, okay, so that corner's taken care of. All right. And looking for unhappy faces. Tristan, are you okay? You good to go? Unhappy faces. Bedela, are you okay? Yeah. Cassandra, are you okay? Okay. Jessica, how you doing? All right. Kenna, how you doing? Kimber? You're Kenna. You're Kimber. My apologies. Kenna, how you doing?
Good.
Kimber, how you doing?
Good.
Okay. And your name was? I'm sorry, I suck. Brooke. I'm so sorry. Brooke. I will get it. I'm sorry. It just. Oh, you're my chicken anyway. So sorry, chick. All right, Brooke. Sorry to call you out. How are you doing? Groovy. Okay. Awesome. And what's your name? Ty. How you doing, Ty?
In the middle somewhere.
In the middle somewhere? Okay. All right. Russ? Yeah. Okay. All right. Austin? Groovy? Okay. All right. That's pretty much everyone. Got everybody. No, Avery, you're good, right? Okay. All right. And you two ladies, remind me. Emma and Kristen. Emma and Kristen. Emma and Kristen. Brooke. Emma and Kristen. Emma and Kristen. Brooke. Ty. And Tyler. Ty and Tyler. And Mitch is back there. And Natalia. Natalia. Brooke. Kristen. Emma. You're just Emma. Emma. Okay. All right, I can do this. I think I've got everybody now. Took me long enough. All right. Groovy, we have 20 minutes. Let's talk chapter 11. Shall we? Sweet indeed.
Not bad. All right.
Actually, I made my own problems.
Did you see it?
Yeah.
Nice.
Just kind of gotta cement it, you know?
Played with it?
Yep, just played with it.
It's a
How'd you
little
check
loose
your
still.
work?
Just gotta
Well, I actually
wrap it
wrapped it too.
secure.
Good.
So I got like a smiley face.
Hot damn.
Yep.
Nice. Synthesizing your own work. That's awesome.
I just didn't know.
Well, that and it just kind of came up in my head too. Like some numbers that just came in my head.
Groovy.
After her office hours?
Oh, but none of these are taken. You really have the reason.
I see if I can get it.
Your answer doesn't have the E to the.
Since you're not Wednesday.
El miércoles no puedes tú.
But everyone else is off.
Yeah, I can't Wednesday. I can only do either today or tomorrow.
Dun, 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 dun.
So it looks like it's me today and then Emma on Wednesday.
Yes.
And
Let's just start with that one.
Or we can just do
Natural log of 8x squared
I have a funeral tomorrow.
It's not
e
even
to the
coming.
2x cubed.
Yes, he did, honey. Just leave it. Go with
Okay.
this. You guys will get a break from me today.
We'll kill two birds with one stone. How would you guys go about taking the derivative of this? So if I ask you to find y prime, by the way, read the directions on this because it's inevitable that when I say find y prime, somebody's going to try to integrate this monster and they're going to be very sad. So y prime is a derivative. And if I ask you to find the integral, what are you going to do?
Inverse.
It's RTFQ. Okay. Because, no, seriously, people try to do it in reverse and they're very sad. They do the wrong thing. And so I mix up, you know how I had a section in the first test of quick derivatives? Now we have a section called quick derivatives and integrals. So each one is going to have its own command, so RTFQ. If I ask you to find y prime, we're looking for a derivative. How do I split this up?
Derivative over the original or the
Yep.
first?
Except that's a knucking nightmare, right? Because that's a what inside?
That's a product, so
It's
there's
a
a little
product.
shortcut to do m plus n.
Yes. So y equals the natural log of m plus the natural log of n. So this is straight out of the handout, because I had a question on it. So, is this bite-sized? Easy, right? Is this bite-sized?
Yeah,
Yeah. Could we simplify it even further?
yeah.
The natural log of e to the anything equals, it's on your tattoo, guys.
Runs away.
It's-
Oh. Dude.
It's okay. You can still do it the long way. I'll show you the long way. Y prime equals 16x over 8x squared plus, let's see, 6x squared e to the 2x cubed divided by e to the 2x cubed. What cancels?
That's why, okay.
Yeah. This is still correct, guys. It's just a little messy. What's the derivative here?
Darn, it got us in the extra
16x over 8x squared plus 6x squared. Still get the same answer. One's a little easier to do though. Always look for the shortcuts. Does it make sense, Caitlin?
Yeah,
Awesome.
I just like, you really have to know those shortcuts then, because
Mhm.
I would have been like, oh, it needs the e to the u at the end.
That's why there's an entire third of your tattoo devoted to those shortcuts. Because my goal is to make your life easier, but you need to be able to recognize what's there. What if I give you this? That's just evil, but you guys had one like this in your homework. What's the derivative of y equals 6 to the x cubed? So find y prime.
18x.
Third.
18x.
Oh, yeah, third, and then you multiply,
So start with your derivatives, guys, because I'm asking you to find a derivative. Does it look like derivative number 1 on your tattoo? No. Does it look like derivative number 2? No, it's base constant, not function. Does it look like derivative number 3? No. That's base e. This is base 6. Okay, e is a different number from 6. Does it look like derivative number 4? No, there is no natural log. So go to the right-hand side of your tattoo and look for something that is constant to function. And tell me what the derivative is going to be. 18x squared times what? It's not 18x squared.
Is it the a to the u one or the a to the x one?
Is it a function or just an x? Up here.
It's an x.
It's not just an x, it's an x cubed.
sort of the u.
So it's a u.
So it's a u.
So what's my derivative, guys?
So x to the third. No, 6 to the x.
6 to the x cubed
Yeah.
times
The derivative,
the derivative of the exponent times
the natural log.
the natural log of the base. It's all there. It's all there. So if you need help, ask your neighbors. They'll point it to you.
There will be
It's okay,
tears.
guys.
There
So
will
on
be
here,
tears on
a
this exam.
represents a constant.
A is a constant. Yep, so on your tattoo somewhere it says A is a constant. Ferris.
I just forgot, why is it 16 over 8x squared?
What's this, the natural log of u is u prime over u. So what's u prime? 16x. Corwin. I can't hear him, guys. Corwin.
Do we have to simplify that?
No. No. You can't simplify this. No. Yeah. You can't simplify it. What about this one? And I ask you to find y prime. It is 3x cubed times e to the 4x.
I'm doing it.
You're doing it?
Yeah, I'm trying. In my
Okay.
head.
Okay. This is not an in your head one,
Why?
because it's not a straight derivative, guys. What is it?
It's a product.
Yes. It's a product, everybody. So what's u prime?
It's gonna be 9x squared over 3x to the third, right? Oh, you're just, sorry.
And what's
I was
b
writing
prime?
the first part.
Yep. What's b prime?
4x. Oh, 4.
Natural.
Oh, yeah.
4e to the 4x.
Yes, Caitlin.
Are you ready for the whole thing?
Yeah, what is it?
Why is that not
9x squared over 3x to the third. Hold on, I'm trying to
No.
remember
U
the
prime
part.
v
Yeah,
It's
plus.
on your tattoo. Don't try to do it from your head if you can't remember it. Just look at the tattoo. What's the product rule? U prime v plus u
plus v prime,
times v prime.
or sorry, times v prime. U times v prime.
So if I were to
Wait,
simplify
How
this,
come you don't put, wouldn't you do
Why is
you're
that?
doing it the long
Where?
way. I thought you would use the shortcut of like.
there is no shortcut for this.
Is that x squared or cubed?
Oh.
Where, Chandelier? In the green?
No.
'Cause it's
In the blue.
In here? Okay. Oh, it should be cubed. Chandelier gets a point.
I was thinking of like, I was thinking
Good
of
job,
natural
For
logs.
the first time.
I was thinking of using the
Yep. But it's not a natural log, so you
I know.
can't use M and N.
Thank you.
I know.
You can't, you can't, you can't.
I have a question.
I have an answer.
Why does 4x, like 4e to the 4x stay? Why does 4x stay like that?
Okay, so if v is some e to a function, what does your tattoo say about those kinds of derivatives? So look at your hang tight Marco and Adam to the left hand side, my dear. So look for your e to the exponent derivatives.
So
So u prime e to the u. So if my function is e to the u, its derivative is u prime e to the u. Hang? Okay, you quick.
Basically.
Hey, man.
Yeah,
Yeah, that's right. Yeah, v to the u.
12x cubed.
And when you take derivative.
What the hell is that? I don't
the
even know what that
derivative
is.
of u, the derivative of
You're all
u.
wrong.
And then
Wait,
you
is all
rewrite.
three of you?
Yes.
All four of
So
you?
v is irrelevant?
All four of you?
Yes.
Son of a
She was
biscuit.
just labeling which one's
Like,
u
why
and which
is
one's
it-
v.
It's like prime. Why is it?
Adam.
Like, why does 4x stay like that?
Autumn.
Well, because v is the original function,
Amon.
and then v prime is derivative of that.
And who else was back there? Marco.
Just 4?
F my
Because one
life.
of the x overlaps.
You're welcome.
Make more mistakes.
It was 4, that's why it was,
So
it's
many
4 in
more.
the
Okay,
beginning,
F
and then
it.
you rewrite the function. That's the way that works. That's
No,
why
you know what?
it's
That
4,
12 was right.
and e
Son
to
of a.
the 4x.
Okay, hang on. U
Because this
prime,
says
uh-uh,
you have this thing,
times v.
and then when you take derivative,
Oh,
you
dear
get the
God.
derivative of,
Plus
of
u.
4x, which was 4.
3x
And then you
cubed, not
rewrite e
squared,
to the u,
times
e
v
to the
prime,
u.
times
And e to the
4.
u
It
is
should be x
e
cubed,
to
right?
4x.
Not squared. That's where I went off. 4e to the 4x. And so this becomes 9x squared e to the 4x plus 12x cubed e to the 4x.
I got you on my stuff.
You did. It's okay. No worries. 3 points for everyone. You get a point. You get a point. You all get points. Ah! All right. The integrals should be really fresh in your mind, guys, because we just did them, right? So on your handout for review checklist on chapters 10, 11, and 12, let's review this really quick. Understand how to find F double prime. Can we do that? Yeah, in our sleep. Know which functions yield y, slope, and concavity. If you forget, it's written on your tattoo, right? What gives you y? Where do you go to get y values, guys?
Forming an x of a function.
The original function. Where do you go to get concavity? Second derivative. Where do you go to get slopes? First derivative. Great. Be able to use test values and critical values to ID regions of slope, concavity, maximum, minimum, points of inflection. I'm not going to give you the test value stuff. Just work with the critical values, knowing where they are and what they are, okay? Know how to find max profit and points of diminishing return. Groovy, we talked about that on the board. Be able to set up a graph in a window to properly show points of diminishing return. Talked about that on the board. Understand relationships between logs and exponential functions. Boy, we did that right here and right here. Right?
And then you cancel each other out.
Okay,
When
be
you
able
have a
to use
function that has
tattoo to
L and
rewrite
E,
logs into derivable forms. Did
delete
one just
L
like
and
that.
E, and the
Know how to
result is the
recognize
answer.
and perform various
So
derivatives.
that's why
Peel the
result is
onion.
2x to the third.
That was a product.
They cancel each other out.
So we're peeling that onion, right? Be able to use logs and exponents in applications. Nothing's different. If I ask you to find the maximum using an exponential, you should be able to do that, taking the derivative, setting it equal to 0, and solving for x. You guys know how to do these. Be able to use, chapter 12, understand how derivatives and integrals are linked. Remember the stuff on the bottom. Profit is revenue minus cost. R of 0 always equals 0. Revenue is price times quantity. Average cost is cost divided by x. Fixed cost is where x equals 0. It is not always k. So that's just one reminder. Okay, k does not necessarily equal 0. K does not necessarily equal fixed cost. You must walk through the process of finding k for each and every application problem when you're doing integration. Ruby? So, in like the 7 or 8 problems we did on the board, we tackled everything on this page. Damn. You guys ready? All right. Again, if you have access, come talk to me immediately about